glasses. You can see it. Let's go back and find, I want to answer this ADA thing in a second. Let's go back and find one that actually has the sine 2. Tangent, tangent, tangent. Well, no, that's just tangents. Just do trig table. I did. Not shopping, I'm gonna buy one.
Would you like to buy a trig table?
Nah, we're good. Yeah, this will do. This will do. So, here's your angle in degrees. Same as the angle we had before. It looks like they go 1 through 90, just like our table did before. There's 45 degrees right there, 45 halfway. The tangent is now in this column over here. It's this column over here. And this column, say the tan, T-A-N, just abbreviated. The other two are called sine and cosine. They're very, very useful if you're doing a lot of geometry in your careers. I'm sure you'll learn these at some point. But they're two different ratios. The tangent is the rise over the run. By definition, it's the grade, rise over the run. The sine is the rise over the hypotenuse. And the cosine is the run over the hypotenuse. Now, some of you might be wondering, what the hell is the cosine good for? Don't worry about that. It's good for not a whole lot in this class. It comes in handy for other stuff. It does. But do you see how the sines and the tangents, when the angles are small, are pretty close? Now look, right there at 3 degrees, they start getting a little bit different from each other. Let me get these lights. It's hard to see. Graininess of it. Okay, we're at 7.5%, yes, ish. So we're getting right around here, which means that we're between 4 and 5 degrees as far as our tilt of our ramp goes. That's where our grades are. But let your eyes come down. Let your eyes come down. They're still pretty close, right? Still pretty close? Still pretty close? Pretty close, pretty close, pretty close. And then you get down far enough. This guy here is at 0.5. I can't even read that one. 0.5. That's just a bad copy. 0.5 and 0.577. Well, now you're off by 8%. Now you're like, holy crap, that's actually pretty sizable. That's a pretty sizable difference. And when you get down to that 45 that I mentioned before, you know that the grade of a 45 is 100%. Because the rise and the run are equal. The rise and the run are equal. But the sine is only 71%. Because the hypotenuse is much longer at that point than the leg. So you're dividing by a bigger number, which means you're getting a smaller number overall. And then if you keep going, look what happens. Look what happens. Above 45 degrees, the tangent goes over 100%. Why does that make sense again, for a tangent to go over 100%? Why does that make sense? How can a tangent go over 100%? I don't get that. How can a tangent be more than 100%? I don't get that. I'm freaking out up here. I'm freaking out. Why can a tangent be over 100%?
Because it's above 45 degrees.
But that's the question. Why? Why does it make sense?
Reasons.
Reasons. I'm looking for a reason. What does it mean if it's over 100%? What's longer?
The hypotenuse.
Careful. Tangent has nothing to do with the hypotenuse. Good point, though. Tangent is only rise and run. If it's over 100%, the rise is longer than the run. So if your rise is 1.1 feet and your run is only 1 foot, you have 110% grade. 1.1 divided by 1 is 1.1. 110%. You don't often see those. You never see those on the roads. I mean, they're too unsafe, unless you're in Seattle or San Fran, but even then you don't see them. You see them on trails sometimes. You call them cliffs. They look like cliffs. And you drop off. Double black diamond runs up the Bachelor. Fair? And now look at the tangents. And look what happens to them as the angles start getting very steep. 290% grade. 567% grade. 2,863% grade. And then if you go all the way to 90 degrees, it says something you told me on the first day. Undefined. Because at 90 degrees, Brittany, I think you said it last week. You said it's all rise and no run. Dividing by 0 gives you an undefined slope. So clearly, at some point, the angles get so large that the tangent and the sine begin deviating meaningfully. But they don't deviate too far on like normal things like roads and ADA ramps, which is why it's okay to calculate things the wrong way. when you have slight angles like that. Does that make sense? You guys buying that logic? So if you need to get a grade approximation, you can simply use the odometer of your car and your elevation app in your iPhone and get a pretty good working idea of grade. It works great because there are plenty of free apps in the App Store and also on the Android operating system that just give you elevation. Where are you above sea level? So you can mark it at the beginning, mark it at the end, calculate the difference, and that's how far you went. But then it'll also track your GPS, for example, won't track your run, it'll track your hypotenuse distance. So if you divide your rise by the hypotenuse, you arguably get, unless you're climbing some crazy angles, you're arguably getting some pretty close estimates to your grade. Fair. Please, Chad, go.
I have a question.
Yes!
What's sine and cosine again?
This is rise over run,
Yep.
rise over hypotenuse, run over hypotenuse. There are also 3 more, which are the inverses of those 3. So run over rise, hypotenuse, don't worry about those though. These are the big ones, the important ones. And honestly, if you have one of them, you don't even need the other 2, which is why I'm not even going to talk about anything past sine other than that. Tammy, go ahead.
It's an easy way to remember that the sign is the wrong way because it's spelled like sin. It's the wrong.
Oh, clever. If you look down on your calculators, there are 3 buttons on your calculator: sin, cos, tan. Sin. That, unfortunately, it's only the wrong way when you're doing grade. It's actually the right way for a lot of stuff.
Right, but I mean, it's pertaining to this.
I know what you're saying. For this particular class, that's good. That's good. So here's what I want you guys to do now. We have 10 more minutes. I want you guys to practice the other 2 ramps, and then we're going to check to make sure that the ramp is ADA okay. We know what the grade's supposed to be. Maximal. We're going to check the other 2 now. So I'm going to put those on this board. I'm going to erase all this out.